Okay, hi everyone, I'm Sam from Archain, and today I'm going to take you through building a basic Archain application. Actually, two basic Archain applications. Archain applications are essentially custom nodes in an Archain network that allow you to listen in on data that's passing through the network and process it. So the first app that we'll be making today is a simple network monitoring app, which will print when new blocks are found in the network. And the second app we'll be making is slightly more complicated and looks at extracting stock data from transactions in the network. So the first thing to note is that I'll be attempting to make this as accessible as possible for people that are not used to Erlang. But I will also be putting some links to resources in the description of this video so that you can find out more about the basics. The second thing is that all of the APIs that I'll show you in today's video are subject to change because Archain is in active development. But everything that you can do here, you will be able to do in the final version. It just might have changed the API calls ever so slightly. So let's get started. The first thing we'll do is we'll build a new app_mon.erl in our Archain source directory. So when you're building an Erlang module, the first thing you need to do is you need to give it a module tag. So we'll say app_mon here. And then we need to say what are the functions that are exported from this module. And here we'll say start/0, and that means the arity of the start function that we'll make public, so accessible outside of this module that we're editing, is 0, so it doesn't take any arguments. And also we'll have a new_block function which takes 1 argument. So we're going to be using the Archain record definitions and in this program, and in order to do that we need to tell Erlang to include the header file, which is just called AR for Archain.hrl. Okay, so now we'll define the start function, which is simply start brace because it takes no arguments, goes to, and here we call the ADT_simple module. ADT_simple abstracts away the complexity of building Archain nodes and provides you with a simple interface whereby you provide a module, and if that module exports the appropriate functions, it'll call those functions when those events occur. So in this application we have a new block event which will be processed by our program, but no other ones. And so this takes away all of the complexity of building recursive nodes, essentially. So we'll call the ADT_simple module the start function inside that, and that takes 1 argument, which is the name of, or rather there are other arguments you can pass to it. For now we're only going to give it 1, which takes the name of this module, which is provided by the $module automatic macro. So what this is essentially going to do is it's going to start an abstracted Archain node that's going to call back to our new block function at the appropriate moment. So now we need to define our new block function, and this just takes 1 argument. We'll call it b for block, and we'll call the io::format function, which takes a format specifier, which we will define as this block number : and the $p, which means pretty print the first argument from our argument list, and we'll say also number of transactions, and we'll say $p again, dot and $n. So $n is just create a new line. So we finish our format specify string, we provide the argument list, which is just b hash block dot height. So this will fill in the first tilde p with the block height, and then we'll get the length, which is a built-in Erlang function, so it doesn't need a module, so it doesn't need module colon length, just length is fine. B hash block dot txs, or rather it's not built in, it's just auto imported from the Erlang module. So there we go, we'll finish that, and that's our first Erlang Archain app, and this will run in a network of other Archain nodes that'll be miners and potentially other services, and so it'll receive all of the messages that they would receive. So now we'll go to our terminal and we'll start running the Archain environment. So we say /stroke Archain-server. We're running Linux here. It might be slightly different on Mac and Windows. So now we've compiled the system. We're going to first start a network. So we'll say peers, new variable, equals AR underscore network, and we keep all of the core Archain modules with the AR underscore prefix, and that's essentially because Erlang doesn't have namespaces, so this allows us to keep our code neat. AR underscore network start. So we'll start a network of 3,000 mining nodes. Each of those mining nodes will be connected to, say, 10 other nodes. So that's started for us. So now we've got a simulated network of 3,000 nodes. And that's what we'll be using to test our Archain application. Later, when the Archain network has launched officially, you'll be able to plug into the real network and run your code on there. But for now, we're just testing. So we've generated a simulated network of 3,000 nodes. Next, we create a new application monitor node. So we'll call it appmon equals app underscore mon colon start. And this takes no arguments, so we run it. So now we have ourselves an app monitor process running in the background, and we've got the process identifier here that we can throw around. So the next thing we want to do is add the appmon to the network that we've created. So we'll do that by saying AR underscore node add underscore peers. Now we're only adding one peer here, but it's the same entry point to the API. So we'll add that node, our app monitor node, to say, I don't know, the 1500th node in our network, just to show that it could be added anywhere and the messages will eventually get to it. So we'll say peers, so number 1500 of the peer list, yeah, and we'll add appmon. Great, so now we've got a network of 3001 nodes, 3000 miners that aren't mining yet. We have to manually ask it to mine at the moment, because otherwise if you had 3000 nodes mining at once, it might get a bit difficult for my laptop here to handle. So we've added the app monitor node to the network. Now all we need to do is tell one of the nodes in the system to mine. So we'll say AR underscore node lists nth, I don't know, we'll pick the 2000th one, and there we go. And we'll just tell it to mine. And as you can see here, it says started miner, mine, and then block number 1. And this block number, this output has come from our Archain application over here. So that's great. Now let's work on something slightly more complicated. So let's start a new app called app underscore stocks.l, and we'll say dash module app underscore stocks, just like before. And we will say this module exports a start function, but this time it's going to take one argument, and that's going to be the ticker of the stock that we're interested in gathering data about. And it also, instead of a new block, it ties into the new transaction event, and that function takes 2 arguments this time. Now, here we're going to use the ADT_simples state management system, and essentially what that does is it provides our module with a state variable that we can change every time it's called. So we might receive one transaction. Say we were building an application which counts the number of transactions or something that we've experienced on the network. So you might start the state at 0, and then every time you receive a transaction, you just return the previous state plus 1. And next time that function is called, it'll be called with that 1 added to it. And that way you could implement statefulness in your simple Erlang Archain application. So we need to include our ARHRL file again, because we need to access the transaction records this time. So we'll define our start function. So our start function takes a stock ticker, which we'll call ticker, and it calls ADT simple again with the start function. But this time, rather than just passing in the module name, we also pass in the starting state. Now, our state in this application isn't going to change. It's just going to be the ticker each time. So here we just pass ticker. That's fine. So then, when a new transaction is experienced on the system, we take the state as the first argument, which is ticker. And as the second argument, we get the transaction, which we'll just call t. So now we're going to call a function we haven't yet defined, which we'll do in a second. So this is just going to count occurrences. We'll call it count substrings. Count instances. Okay, fine. So that's going to take the ticker and the t hash transaction.data, and it's going to return a number that relates to the number of times the ticker has occurred inside the transaction data. So the transaction data will be the archived information on the chain, or the weave rather, and so that's where we'll find our web pages and so on. So we're searching those web pages for instances of our ticker, and if there are no hits, then this isn't for us. We're not interested. This transaction is not for us. So we'll just return the state unchanged. We'll just say ticker. But if we do have a hit on the ticker, what we'll do is we will call IO format again, but this time we'll say stock data for, and we'll say ~s, which means format a string, by colon ~p, cell colon ~p, and ~n for a new line. So now we pass our list of arguments, and the first argument we're going to give is easy. It's just ticker. So that's going to fill in the ~s here. And the second two arguments are a little bit more complicated. We're going to count instances again, but this time of by in t hash tx dot data, and we'll duplicate that line, remove that, but change this to cell. So now we're extracting the number of times a piece of data that speaks about the ticker we're interested in mentions buying or selling. So this this is a very crude metric, but it can show you what the sort of things that you might be able to build with the Archain ADT. Obviously, you can make it much, much more complicated. And so we return the ticker unchanged from this function. So now all we need to do is go and implement that count instances function. And I won't get too much into the details of this. It's Erlang specific. It's not related to the Archain. But very quickly, we take the target and the string goes to, and we will say case RE. That's the regular expression library, which is what we'll be using here. Obviously, you could use other more efficient ways of doing it if you're just matching the string, but this is easy enough for us. So we're looking in the string for the target, and we need to say, give it a list of options, and the only option is the atom global. And this just essentially means return all of the matches, not just the first one, if there are any, that is. So that might return the atom no match, which means that there are no instances of the target string inside the string. So we return 0 then, or match, and a list of matches. So we'll call that matches. And then we will simply return the length of matches. Okay, fantastic. So we've got this here, and we will add it to the same network. So first we've got to rebuild, and we can see here that it's picked up our new app stocks. So we'll start ourselves an app stocks, which we'll say app underscore stocks. Oh, sorry, that's my other one. And we'll start, and we'll look for the ticker Goog for Google. Fantastic. So now we add that stock application to the network, just like we did before. So AR underscore node, add peers, and we'll add it to, I don't know, 500 this time. So the 500th peer in our network. We will add app stocks. Fantastic. So now we're going to create a transaction. We can do that simply by saying t equals AR underscore tx colon new. And you can find out all sorts of information about the library that the Archain ADT provides for you, but just by browsing around the source code or looking at the documents online. Everything is commented, so you should be able to understand it. So here we're making a bit string, and Goog, I don't know, maybe this is a web page that's saying Goog, good to sell today. Who knows? So we make the new transaction, and now we simply submit that transaction to the network. So we'll pick another random node. This nth, don't know, 1300 this time, from the list of peers, and we add t, the transaction. Aha! And now you can see here that our application has caught on to the fact that there was a new transaction about Google, and it says stock data for Goog, buy 0, sell 1. So it's triggered our application. We've got some useful information out of it. And because it's running in the same network as our previous custom application, so we've got 3002 nodes here, 3000 miners, and two custom nodes. We can also see what happens when we force a node in the network to mine again for us. So we'll say, well, let's go back here, but not the 2000th, I don't know, who knows, 200. And we can see here that this has triggered our other application. So block number 2 has been mined, and it's got 1 transaction in it. So there we go. That's making basic applications that run on the Archain, currently in a simulated network, but you could run this in the official network when it launches. I hope this has been helpful. Thanks.